Now we have one more activity to understand that liquid exerts pressure in all direction. So in this activity we are going to know liquid exerts pressure in all direction. So first one is take a plastic mug and water in a bucket. So you have to take one plastic mug, you have to do this activity. Now pour some water in a bucket. So after the pouring water in a bucket, invert the mug and try to press it so as to immerse the mug into water. Now you have to take the mug and now invert the mug and try to press it. Now try to immerse that mug in the water. Now see what will happen. So you will experience an upward push on your hand. So this is because of the pressure exerted by a water in the upward direction. So here in the water the pressure is exerted in all direction. So here the pressure is exerted in the all direction. So this is the reason why you are not able to immerse the inverted mug into the water. So thus liquids exert pressure in the upward direction also. So we have one more activity to understand this. Now take a balloon, fill it with water. Now you can do this activity in your home. Take a balloon, fill it with water. Now tie its mouth. Now you have to tie the mouth of the balloon by using a thread. Now make holes in it by inserting a pin at several places in all direction. Now make holes, that means you have to make several holes on the balloons by taking a small safety pin at several places in all direction. What you will notice, students, so water will flows out through each hole. That means water will start to flow from each hole. So from this activity what you understood is that liquid exerts pressure in all direction. That means liquid exerts pressure not only on the sideways but also liquid exerts pressure in all direction. So this shows that water in the balloon exerts pressure in all direction. So now we will move on to the factors affecting liquid pressure. So here we have two factors. One is the height of the liquid column. That means a liquid pressure increases with height of the liquid column above the point. And the second one is the density of the liquid. Liquid pressure increases with the increase in density of liquid. So these two are the factors. Now let us study about these factors of a liquid pressure one by one by using a few activities. So first one is liquid pressure increases with the height of the liquid column. So here they are saying liquid pressure increases with the height of the liquid column. Let us understand this by a small activity. So already you know about this activity. Now take a glass tube, open at both ends, hold it vertically. So you have to take a glass tube and you have to make a open at both the ends, hold it vertically. Tie a balloon at the lower end. Here you can see in the orange color a balloon is tied at the lower end. So pour some water in the tube. Now you have to pour some water in the tube. You will notice that the balloon bulges out as shown in the figure 3.2a. So you can see the balloon is bulged very less here in the figure 3.24a. So because I have poured very less water. So similarly, now I am going to add some more water to this same glass tube. What will happen then? So here you will find that the balloon bulges more. Here you can see in the figure the balloon will bulges more. So why the balloon is bulging more? This shows that the greater the height of the water column in the tube above the balloon, greater is the pressure exerted by it on the balloon. That means if the height of the water column inside this glass tube is very high, then the pressure exerted by the balloon will also be very high. Here in the first case, you can see the height of the water column is very less. The pressure exerted by liquid is also very less here. Thus, the liquid pressure at a point increases with height of the liquid column above that point. That means to increase the liquid pressure in a vertical column, you have to take a more quantity of a liquid, so that pressure will increases. If you take very less quantity of liquid in the glass tube, the pressure will also be very less. Now let us go for other activity. Now take an empty tin cylinder. So make two holes in it, A near the top and B near the bottom. Here you can see a hole is made at a top and one hole is made at a bottom. So the top hole we call it as a A and the hole near the bottom we will call it as a B. You can see in this figure. Now close the holes A and B with an adhesive tape. That means by using the tape we are going to close the holes A and B. Now place the cylinder on a block kept on table. Now we are going to keep this cylinder on a block kept on a table. So that means block means here, see this is of a wooden block or a stone block. So it is a block. Now we are going to place the cylinder on a block which is kept on a table. Now what you are going to do is that fill the cylinder with water. Now you have to take some water. You have to fill the cylinder with water. Now remove the adhesive tape from the holes. Now you can see here, now remove the tape from the hole, this A and B. When you remove the tape, what will happen there? So here you will notice that water is coming out from the upper hole A, falls close to the cylinder, and the water coming out from the lower hole B falls farther from the cylinder. That means when we open the tape, from the both holes the water will start falling. So this shows that liquid pressure at a point increases with the height of the liquid column above it. That means liquid pressure at a point increases with the height of the liquid column above it. That means here I am going to consider a liquid point B. So here it is also got pressure and liquid point A also has got some pressure. So here how the liquid pressure increases means with the height of the liquid column above it. That means you can see the column A. On that point A we don't have any liquid. Here you can see point A, we don't have any liquid here, but you can see on the point B, you can see the liquid column above this point B. Now this is the assignment for you. Now you have to tell me in which hole the pressure will be more, either in the point A or point B. So here the point B has got some more pressure because a point increases with the height of the liquid column above it.